Okay, from our previous video and from the previous slide, we already solved the cross-sectional area. uh, Cross-sectional area, we have the weighted parameter, we have the slope. So solving that equation, we come up with the q of 0.6 cubic meters per second. So ang next question was, if we will change the slope, the bottom angle from 0.3 degree to 1 degree, we have to determine the q. So changing it, so instead of 0.00523, mahimo siyang 0.01746. So plugging into the equation, it will give us a q of 1.1 cubic meters per second. Okay, so if you have a question for this example, you can just type uh, in the reply portion of this post. So in the discussion, note that the flow is a strong function of the bottom angle. So yeah, ang q, uh, the factors determining the q are the slope and the hydraulic radius and the velocity. And dako kay na siya factor ang slope. So just by slightly changing the slope, so dako kay change ang iyang flow. And also there is a considerable uncertainty in the value of Manning's coefficient. So Manning's coefficient of n, so if you look at the note of the table, na siya 20% nga uncertain, so na plus siya, plus and minus 10 nga uncertain siya. So na kay it can be 10% bigger or 10% smaller. So there's a 10% uncertainty in the flow rate. So final answers are therefore given to only two significant digits. Okay, so this is an example of a field of civil engineering that's not an exact science. In fact, almost all fields of civil engineering is not an exact science. So it's just a form of approximation. But we can say that it's a relatively accurate approximation. But it's not an exact approximation. It's just um, accurate relative to its application. Okay, so this is not an exact science, just like in the other subjects or in the other field of civil engineering. It's not an exact science. So another example, so water is to be transported in an unfinished concrete rectangular channel with a bottom width of 4 feet at a rate of 51 cubic feet per second. So the terrain is such that the channel bottom drops 2 feet per 1,000 feet. So nanatay slope nga 2/1,000. Okay, so we have to determine the minimum height of the channel. So pila ko na height under uniform flow conditions. What would your answer be if the bottom drop is just 1 foot per 1,000 feet length? So mana siya ang first condition. Second condition is 1:1,000 nga slope. So nanatay q, volumetric flow of 51 cubic feet per second. So again, we'll use the Manning's equation. Anyway, it will be specified in the problem, and kung dili Manning's equation ang gamiton, let's say mingon ang problem nga, use the cutter C, use the basin C, tagaan mo value sa M. So ano siya, same assumptions. So for Manning's coefficient, for unfinished concrete, we'll use 0.014. So Again, we need to solve for the area first, but we cannot directly solve for the area because the unknown is the y. So we will solve the area in terms of y. So the area is 4y in terms of y. The weighted perimeter is b plus 2y, or 4 feet plus 2y. So the weighted perimeter or the hydraulic radius is in terms of y. So that is the hydraulic radius, 4y over 4 plus 2y. So bottom slope is 0.02. So use this one to our equation. We have 51 cubic feet Q. Then since it is in English, so we need to use this 0.1486 or 1.486 nga factor. So that's the area, that's the weighted perimeter, and the slope. So you can use your calculator. The only unknown is y. So although y is not linear, yeah, he can solve using equation solver or Excel or whatever. But you can just simply use your calculator. I know you're very good at that. Use your calculator to solve for the unknown value. So you can solve for y is equal to 2.5 feet. Okay. So what if we will change the slope from 2 is to 1,000 to 1 is to 1,000? Pila man kay value? Okay. If the bottom drop were just 1 foot per 1,000 feet, so the flow would be, or the flow depth would be 3.3 feet. So mo dako siya because mahinay man ang velocity. Okay. So note that y is the flow depth, and thus this is the minimum value for the channel height. Also, there is considerable uncertainty in the value of man excavation, and this should be considered when deciding the height of the channel to be built. So in the actual practice, you must always put an allowance because there are parameters which are uncertain. Mara sa limit sa knowledge sa designer. So another example, we have a irregular cross-section of a channel. Aside from irregular cross-section, it is composed of different property. So the bed on the right side is, I think in the actual, this is a floodplain area. So floodplain area, so there's a light bush. Mahitabo gud ana. There's a natural channel. Then there's what we call the floodplain. Then floodplain area, matubigan lang na siya kung magbaha. So that's why ang iyang N is light brush. So naa siya yung mga tanom-tanom nagmay. So mas bigger ang value sa iyang N, is 0.05. Then for natural channel, naturally or typically wala ni siya kay obstruction, so slightly lower, 0.03. We have to determine the Q, the total. We have to determine the flow rate through the channel and the effective Manning's coefficient for the channel. Like the entire pila may N kuno for the entire channel. Kaya lahi-lahi man siya. So ato na siyang i-equate later. Kuhaon sa nato ang flow rate. First, we need to determine this one, flow rate. So since we have an irregular channel, so we must divide the area into two. So we divide na to ang area. So the bottom slope is 0.03. So for this one, again, those are the assumption. The flow is steady, the bottom slope is constant, and Banning coefficients do not vary along the channel. So first, we must determine the area. So we must first determine this side, the length of this side. Kini, I think it is 3. So square root of 3 man siya, 3, 3. So, squared 9 is 9. So, we can determine that one, the value of S. Yeah, square root of 3 squared plus 3 squared. So, it's equal to 4.24. Then, the area. So, we will subdivide the area into 2. So, okay, irregular man ang area. So, subsection 1, cross-sectional area is 21, perimeter is 10.486. So, getting the ratio, the area and perimeter, that's 2. Then, also we need to solve the cross-sectional area 2, the 16 square meter. Perimeter area is 10. Then, RH is 1.6. And then we combine the area, the entire channel. So, this is the area of the entire channel. That's the weighted perimeter. Then the RH is 1.86. Okay, so use the Manning's coefficient. Use the Manning's equation for each subsection. So the total flow rate for the channel is to be determined. So Q1 plus Q2, the total Q. So ano lang, add this one. Then we can have a total Q of 85 cubic meters. 84.8, roughly 85 cubic meters per second. So knowing the total flow rate, so kabalo naman ta, so we can now solve for the N, effective N, which is 0.035. So it's between 0.03 and 0.05. Yeah. Okay. Okay, so I think that would be all for this topics discussion. So I will just upload, or I will just give you problems to solve for your plates. So good afternoon everyone. Thank you for your attention and time.